Today's lesson is Chapter 6, Lesson 1, Percents and Decimals. Our essential question for this lesson is, how does the decimal point move when you rewrite a percent as a decimal and when you rewrite a decimal as a percent? You've probably learned this in the past, so this is probably just a review lesson, but let's go through this anyway. Our only vocabulary word for this lesson is percent. So that's a good place to start. What does the word percent mean? Well, if we break down the word, we can break it down into two parts, per and then cent. Per means for every. So per means for every, or we could say it's for every, or it could mean out of. Okay, so per is out of or for every, and the word cent means 100. So if we put those two things together, percent means for every 100 or out of 100. So let's give that. Out of 100 is really what percent means. Our key idea for this lesson, writing percents as decimals, remove the percent symbol, then divide by 100, or just move the decimal point 2 places to the left. So right here. So when we're rewriting a percent as a decimal, we're going to remove the percent symbol, take it away, and then we're just going to move the decimal point 2 places to the left. When we move the decimal 2 places to the left like we're doing here, it's the same thing as dividing by 100, all right? Which also means out of 100. All right, so if I had a fraction, 23 over 100, the fraction bar means divide, and the hundred's in the denominator, and this means 23 divided by 100, or it also means 23 out of 100, okay? So let's just go ahead and do some examples. Writing percents as decimals. So letter A, write 52% as a decimal. So the rule that was stated above says remove the percent symbol. So we're going to remove that, and we have just 52. And then it said to move the decimal point 2 places to the left. I don't have a decimal point here, so I have to imagine where would it be? Where could I put a decimal point that still doesn't change the value of the number that I'm looking at? So if I put a decimal point right here to the right, it's still worth 52. So I didn't really change the value, but I did add the decimal point that I can now move. And we have to move it 2 places to the left. So I'm going to 1 place, 2 place, rewrite the decimal point there. This decimal point no longer is the one that we use. And we then rewrite our answer. Now, because we have a decimal point in front of these numbers, we have to have a placeholder for the ones position, for the position right here. So we have to have a 0 out in front of this decimal point. So it's 0.52. In math, we technically don't write decimals without a placeholder in the ones position. All right, so 0.52. Letter B, write 7% as a decimal. So again, step 1 is remove the percent symbol, so just 7. Step 2 would be to move the decimal point 2 places to the left. Again, the decimal point would be to the right of the number if we don't see one. And then we're going to move it 2 places to the left. So 1 place, 2 places, rewrite the decimal point. And if we have any places that are empty, we have to put in zeros as placeholders. And then we can rewrite our final answer. Remember, there needs to be a 0 in the ones position in front of the decimal point, and then our 0.7 will fill in the remainder. All right, if you have any questions on that, please make sure to ask questions when you come to class. But again, this is all just review for most of you. All right, so here's some on your own questions that you can pause the video, go ahead and do on your own, and then turn it back on when you want to check your answers. All right, so number 1, 24%. We're going to rewrite it without the percent symbol. We're going to add the decimal point to the right. We're going to move it 2 places to the left. All right, this decimal point's no longer good. We're going to add a 0 placeholder in the ones position, and we're going to rewrite our decimal. So 0.24. Number 2, 3%. Rewrite it without the percent sign. add the decimal point to the right, move the decimal point 2 places to the left when changing a percent to a decimal, add a 0 placeholder for the empty space, and then rewrite the answer using a 0 placeholder in the ones position. Number 3, 107%. Rewrite it without the percent symbol. Add the decimal point to the right since there isn't one. Move that decimal point 2 places to the left and rewrite it there. This one's no good. Now my ones position has a number in it, so I don't need a placeholder. So 1.07 is our final answer there. And number 4, 92.7, I'll rewrite that without without the percent symbol. Now there already is a decimal point here, so I don't have to add one. So we'll just move the one we have, 1 place, 2 places, rewrite it. We don't have a number in the ones position, so we're going to add that 0 placeholder in the ones position, and then write all of the numbers to the right of that decimal point in our final answer, 0.927. Again, any questions on this? Please make sure you ask questions when you return to class. All right, another key idea. If we're writing decimals as percents, multiply 100 by 100, multiply the decimal by 100, or just move the decimal point 2 places to the right. And then we must add a percent symbol. So we're just going to do the opposite of what we were doing in the previous examples. So let's go ahead and take a look at some of these examples. Writing decimals as percents. Write 0.47 as a percent. So I'll start with 0.47. And all we're going to do is move our decimal point the opposite direction now, since we're going from decimal to percent. We're going to go to the right 2 places, rewrite our decimal point there. So let's see what this would look like. This would be 47, and if we have that decimal point there that we bring down, well, having this decimal point here doesn't really change the value of this number 47, so we would just drop the decimal point and we would end up with just 47, and then we're going to add a percent symbol since we're changing a decimal to a percent. Okay, letter B, write 0.663 as a percent. So I'll start out with 0.663. I'm going to move my decimal point 2 places to the right and rewrite it there. I'm going to rewrite this number, 66.3. Now I can't drop the decimal point here because that would change the value. And then we're just going to add a percent symbol to it. So 66.3%. Letter C, write 1.8 as a percent. So I'll start with 1.8. And I'll move my decimal point 2 places to the right. Rewrite the number, 180. Now I'm going to drop the decimal point because the decimal point over here to the right of the 0 doesn't change the value if I drop it. So I'm going to drop the decimal point. There's nothing to the right of the decimal point, so there's no reason to have it. And then we'll add our percent sign, 180%. Write 0.009 as a percent, 0.009. Move our decimal point 2 places to the right, rewrite it there. So I have all these zeros in front of the decimal point. I really only need one of them in front of the decimal point because the other zeros, none of them add any value, but I have to have 1 0 there in the ones position as a placeholder because we can't have a decimal point to start the number. We have to have a number to start the number. And then to the right of it would be a 9. And then we add our percent symbol to finish out the problem. So 0.009 is equivalent to 0.9%. All right, so here's some problems that you can do on your own. So go ahead and pause the video, do these, and come back and check your answers when you are finished. Okay, so let's do number 5. We have 0.94. I'm going to move my decimal point 2 places to the right. Rewrite the number as 94, drop the decimal point, and add the percent. Again, I'm dropping the decimal point because there's no numbers to the right of the decimal point. I don't need it. All right, number 6, 1.2. I'm going to move 2 places to the right. Let's redo that. I didn't need that 0 in there. I got ahead of myself. I'm going to start with just 1.2. Then I'm going to move 2 places to the right and rewrite my decimal point. I have an empty space here, so I'm going to add a 0. So mentally before I made a mistake, I was already doing it in my head before doing it on the board here. So let's not get ahead of ourselves. So we move the decimal point 2 places to the right. We rewrite the number. Since there are no numbers to the right of the decimal point, I don't need it. So I'll drop it and we'll add a percent symbol. So 1.2 is worth 120%. Number 7, 0.316. Start off with our number. So I'm going to move my decimal point 2 places to the right and rewrite it. I'm going to rewrite that number. I don't need the 0. It doesn't add any value to the number. Keep our decimal point in there because there is a number to the right of it, and then add our percent symbol. So we have 31.6%. And number 8, 0.005. All right, so I'm going to move my decimal point 2 places to the right and rewrite it there. Now again, there are 3 zeros to the left of my new decimal point. I don't need all 3 of them. I only need 1 to be in front of this decimal point. So I'm just going to keep the 1. I need the 0.5 in my answer. And then I'm going to add a percent symbol to finish out the problem. All right, again, if you have any questions on this, please make sure you ask when you come back to class. All right, example number 3, writing a fraction as a percent and a decimal. So on a math test, you get a 92 out of a possible 100 points. Good job. Which of the following is not another way of expressing 92 out of 100? So 92 out of 100 would look like this, 92 over 100. And that was what you got on your test. So that looks like it's a very good score. All right, so we have these 4 choices, and one of them is not equivalent to 92 out of 100. So when they say is not another way of expressing 92 out of 100, it really means is not equivalent to 92 out of 100, not equal to it. So I look at A, and 92 out of 100, if I was to simplify this 92 out of 100, it would simplify. I could divide the top and the bottom, by 4, and I would end up with 23 out of 25. So if I did 92 over 100 and divide the top and the bottom by 4, it would equal 23 on the top and 25 on the bottom. So that is equivalent. So A is not the correct answer. 92 out of 100. B is 92%. Well, what does 92% mean? It means 92 out of 100, which is the same thing as what this fraction means, 92 out of 100. So they are equivalent. So B is not the correct answer. C is 17 over 20. Now, to compare 92 out of 100 and 17 over 20, I need to take this fraction and turn it into something over 100. So if I have 17 over 20, I can multiply the top and the bottom by 5 to turn it into a fraction out of 100. 20 times 5 in the denominator is 100. 17 times 5 in the numerator is 85. 85 out of 100 and 92 out of 100 are not the same. So C is the one that is not equivalent, or not another way of expressing 92 out of 100. And then D, if we wanted to just check D, we have 0.92. If I turn this into a percent, I can move my decimal point 2 places to the right. I can rewrite it. I don't need the decimal point because there's no numbers to the right of it. I can add my percent sign. And we already know that 92% means 92 out of 100, which again is the same as what the fraction 92 over 100 means. It means 92 out of 100. So D is also equivalent to 92 out of a possible 100 points. So that's why D would not be a correct answer. All right. So again, if you have any questions on that, please ask in class. And lastly, our last example for the lesson is a real-life application problem. So the figure shows the portions of ultraviolet rays reflected by 4 different surfaces. How many times more UV rays are reflected by water than by sea foam? All right. So they're asking how many times more UV rays are reflected by water, so out here, compared to sea foam, which is here. All right, so seafoam reflects 25% of UV rays, ultraviolet rays. Water reflects 21/25 of the UV rays. So we're looking at a percent and a fraction. So what we need to do here is we have to write 25% and 21/25 as decimals. In order to be able to compare these two numbers, they have to have the same form. If they don't have the same form, it can be difficult to compare them. So the easiest way to compare fractions, percents, and decimals, in my opinion, is change everything to decimals. All right. If you change everything to decimals, then it's easy to see which one is larger and which one is smaller. Now we're going to go a little bit more than that because it wants to know how many times more. So what factor more is one versus another. So we'll figure that out in a second. To change 25% to a decimal, we're going to drop the percent sign. We're going to add a decimal to the right because there isn't one. So that's where it would be if we added it and it doesn't change the value. And we're going to move it 2 places to the left to change a percent to a decimal. So we have 0.25 and we have to add a 0 placeholder in the beginning. So we have 0.25 for, excuse me, for the percent to a decimal. Now I have 21/25 and I want to change this to a percent. So a percent means out of 100. So what I want to do here is I could do one of two ways. I could just do the numerator divided by the denominator. That's one way to do it. Or I could change this into a fraction out of 100, which would mean the same thing as a percent, and then I could change it to a decimal. So 25 in the denominator, I could multiply that by 4 to get to 100, which means that if I multiply my numerator by 4, it will give me a new numerator. So 4 times 21 is 84. Okay, and 84 out of 100. That's the same thing as this number up here represents percent because it's 84 out of 100. So 84 over 100 is equal to 84%. And then I can change my 84% to a decimal. Drop the decimal, the percent sign, drop the percent symbol, add a decimal point, move it 2 places to my left. So it equals 0.84. But I have to have that 0 placeholder. So now I have 0.25, which is equivalent to the 25%, and 0.84, which is equivalent to the 21/25. But the question is, how many times more UV rays are reflected by the water, which is represented by 0.84, compared to the seafoam? So this is water, and this is seafoam. They want to know how many times more. And the way we figure out how many times more is we take this value that we have for water and divide it by the 0.25. So what we're going to do is we're going to take the 0.84 and we're going to divide it by the 0.25 because this will tell us how many times bigger or how many times more UV rays are reflected by water. All right, so 0.84 divided by 0.25 is equal to 3.36. So what this means, this number right here, it means that water reflects 3.36 times more UV rays than does seafoam. Okay, so more than 3 times. All right, and then we have these 2 on your own questions. So go ahead, pause the video. Take care of these, and then come back and check your solutions when you're finished. Okay, write 18 out of 100 as a percent, a fraction, and a decimal. So 18 out of 100. Well, out of 100, we already said, means percent. So I can just rewrite this for the first part as 18% because percent means out of 100. Okay, so that's takes care of the first one. As a fraction, in order to write 18 out of 100 as a fraction, we just take 18 and we divide it by 100 because again, this division bar means divide, which also means out of. All right, so it's 18 out of 100. And then as a decimal, we can take our 18% that we had up here and change that into a decimal. In order to do that, we drop the percent sign. We have to add a decimal point to the right. We're going to move that 2 places to our left. And then we're going to rewrite it as 0.18 and make sure we have a 0 placeholder in front of the decimal point. So that takes care of number 9. 18 out of 100 can be written as 18%, 18 over 100, or 0.18. And then lastly, in example 4, I'm going to go ahead and erase this now so that we have some room to work. In example 4, how many times more UV rays are reflected by water than by sand? So we got to go back up to this problem up here. Again, we already figured out for water. Remember, we did that right here. So I know that water reflects 0.84 of the UV rays. Sand, it gives it to us in a decimal form already. So sand is 0.15. So in order to figure out how many times more this number is compared to the other number, we're going to divide them. We're going to take the 0.84 and we're going to divide it by the 0.15, and that'll tell us how many times bigger the 0.84 is than the 0.15. So let me go ahead and do that on a calculator. And when we do that, we come up with 5.6. So what that means here again is this number means that water reflects 5.6 more UV rays than sand does. All right, so that's it for today's lesson. We do have some problems here that we would like you to do. So I'm going to just scroll down a little bit. And we're going to have you do a couple of problems from each section. So we're going to have you do number 7. We're going to have you do number 14. We're going to have you do number 18. And we're going to move on down here. We're going to have you do number 19 and number 26. And last but not least, we're going to have you do number 32. So go ahead and take care of those problems. Make sure you show all your work on a piece of paper and turn that into your teacher when you return to school so that we know that you understand the lesson. And again, if you have any questions, if there's anything that you are unclear about, please make sure to ask these questions when you return to class.